Hello, everyone. Black holes are among the formations of the universe that remain obscure. They range in size from a tiny pinpoint to billions of widths. According to astronomers, there are around 40 quintillion stellar mass black holes wandering around in the universe. Stellar mass black holes are found in the observable universe and make up ones of all matter. Stars with a mass thousands of times greater than the Sun at the end of their lives begin to fuse increasingly heavier elements such as silicon and magnesium in their cores. As this fusion process begins to form iron, the star begins to violently self-destruct. The iron takes in more energy for melting than it gives out, causing it to lose its ability to propel against the powerful gravitational forces produced by the massive mass of the star. Then it collapses into itself, first packing its core and then all matter close to it into an infinitely small and infinitely dense singularity point. After all this strife, the star turns into a black hole, and beyond a boundary called the event horizon, nothing, not even light, can escape the black hole's strong gravity. Black holes, as their name suggests, are black. In an endless darkness, it is impossible to see a black hole ready to swallow everything in its path. However, we can see the strong gravitational force exerted by the black hole on the stars and gas around it. If a star is orbiting at a certain point in space, astronomers can tell from the movements of that star whether it is orbiting a black hole. Studying black holes can give us a whole new perspective on the universe. In recent months, astronomers announced that the newly discovered pair of supermassive black holes is the closest to colliding black hole. In today's video, we will examine the details of this news together with you. Astronomers said in a paper published June 9 in the Astrophysical Journal at the American Astronomical Society meeting in Seattle that the newly discovered supermassive land announced that the whole pair is the closest black hole to collision. Although these two supermassive black holes are cosmologically only 750 light-years apart, they will not merge for several hundred million years. Meanwhile, the astronomers' findings provide a better estimate of how many more supermassive black holes in the universe are close to colliding. This advanced count will help scientists listen to a cosmic-wide choruses of intense space-time fluctuations known as gravitational waves, the largest of which is the product of the close collisions of supermassive black holes following galaxy mergers. Detecting this gravitational wave background will improve estimates of how many galaxies have collided and merged in the universe's history. Because of the small separation between the black holes, astronomers were only able to tell the difference between the two objects by combining multiple observations from 7 telescopes, including NASA's Hubble Space Telescope. Although supermassive black holes cannot be seen directly with an optical telescope, they are surrounded by bright stellar bundles and hot gas that is attracted by their gravitational pull. The fact that astronomers found this black hole pair so quickly means that supermassive black holes that are close together may be more common than we thought because we found both and we didn't have to look far to find them, said Menger Lelling, co-author of the study. The newly discovered supermassive black holes are in a mixture of two colliding galaxies about 480 million light-years from Earth. Massive black holes live at the centers of most galaxies and grow by swallowing gas, dust, stars, and even other black holes around them. The black hole Sagittarius, which has a mass almost 4 million times that of the Sun, is located at the center of the Milky Way, just like other galaxies. The two supermassive black holes found in this study are really heavy balls. They are 200 million and 125 million times larger than our Sun, respectively. Black holes came together as their host galaxies crashed into each other. Eventually, they will begin to orbit each other, the orbit narrowing as gas and stars pass between the two black holes and steal their orbital energy. Eventually, black holes will begin to produce gravitational waves much stronger than previously detected, and they will slam into each other, forming a jumbo-sized black hole. Some of the energy created by the collision or merger of two black holes is released into space-time in the form of very strong gravitational waves. We can learn about these strong gravitational waves by measuring them with precision instruments on Earth. In 2019, a large black hole collision was discovered thanks to the gravity detectors LIGO and Virgo. About 12.81 billion light-years away from us, these black holes, 66 and 80, 5 times the size of the Sun, collided to form a new black hole with 100 solar masses. It was observed that the newly formed black hole reached a speed of 200 km per second with the thrust of the merger. From the collision site, NASA's Fermi X-ray Space Telescope picked up a weak gamma-ray signal with a delay of 0.4 seconds. We would like to clarify here. LIGO, the Gravitational Waves Observatory, observed in 2015 that two black holes, 136 and the other 29 solar masses, merged to produce a larger black hole. In the intervening 5 years, the sensitivity of LIGO has been increased, and it has been made much more sensitive by working with the Virgo Gravitational Waves Observatory in Italy. We've since added 50 black holes to our list of merging black holes. However, until May 2019, we could not see a single signal from black holes. In addition, Palomar Observatory's Transient Celestial Events facility detected a rapidly increasing magnetic field burst in the area where the merger occurred. When scientists combined all this, they realized that black holes were actually colliding inside a larger accretion disk. What is more interesting is that this event took place 7 billion years ago. If we go back to our topic, previous observations of merging galaxies had only seen one supermassive black hole. Because the two objects were so close together, scientists weren't able to clearly separate them to observe with a single telescope. The new research, led by Michael J. Koss of Eureka Science in Oakland, California, combines 12 observations from 7 Earth-based and orbiting telescopes. While a single observation was not enough to confirm their existence, the combined data ultimately revealed 2 different black holes. Mingarelli, along with visiting scientist Andrew Casey Clyde of the Flatiron Institute, say they estimated the universe's population of merging supermassive black holes using the new observations and found that it could be surprisingly hot. They speculate that supermassive black hole pairs are abundant and produce large amounts of ultra-strong gravitational waves. All this fuss should result in a high gravitational wave background that is much easier to detect if the population is smaller. That's why the first detection of background noise from gravitational waves could happen very soon, Mingarelli says. What do you think about this discovery? Please share your ideas with us in the comments section and ring the bell to be notified of upcoming videos. See you in another video.